Hello and welcome to G Fun Facts Online. For decades, the pinnacle of creative mathematical reasoning has been a competition called the International Mathematical Olympiad, or IMO. It's an arena where the brightest young minds on the planet grapple with problems so difficult they push the very limits of human intellect. But in 2025, a new kind of mind entered the arena, an artificial one, and it didn't just compete, it won gold. Today, we're diving deep into one of the biggest breakthroughs in AI history, how machines learn to reason like mathematical geniuses. In July 2025, the AI world was shaken by near-simultaneous announcements from two of its titans, Google DeepMind and OpenAI. Both revealed their AI systems had tackled the latest problems from the International Mathematical Olympiad and achieved scores that placed them firmly in the gold medal bracket. To understand how monumental this is, you need to know what the IMO is. Held every year since 1959, it's the World Championship of Mathematics for pre-university students. The problems aren't about simple calculation. They are deep, complex puzzles drawn from algebra, combinatorics, geometry, and number theory. They require creativity, intuition, and logical leaps that feel more like art than arithmetic. Google DeepMind system, named Gemini DeepThink, and a parallel model from OpenAI, both independently solved an incredible 5 out of the 6 notoriously difficult problems. This earned them a score of 35 out of a possible 42 points. In the 2025 competition, that score was the exact cutoff for a gold medal. For context, only the top 8 to 11% of the brilliant human students who compete managed to earn this honor. These are the future Fields medalists, the Nobel laureates of math. And now, an AI sits among them. What makes this even more significant is that it was official. For the first time, an AI was formally graded and recognized by the IMO committee itself. Professor Gregor Dolinar, the president of the International Mathematical Olympiad, confirmed the result. He stated, "We can confirm that Google DeepMind has reached the much-desired milestone. Their solutions were astonishing in many respects. IMO graders found them to be clear, precise, and most of them easy to follow." Think about that. The AI's work wasn't a jumble of code. It was elegant mathematical proof, understandable to human experts. While Google's model was formally certified, OpenAI confirmed its own AI achieved the exact same score, under the same grueling exam conditions. 2 4.5-hour sessions with absolutely no internet access or other tools. It was just the AI and the problems. Interestingly, there was one problem that stumped both of these AI powerhouses. The final, killer question known as P6, a notoriously difficult combinatorics problem. This same problem was a massive hurdle for the human contestants too, with only a tiny handful managing to solve it completely. This tells us that even at this incredible level, there are still frontiers of human creativity that machines are yet to conquer. But the story gets even more incredible when you look at how the AI achieved this. It wasn't just about getting the right answers. This 2025 breakthrough represents a fundamental leap in how AI reasons. You see, just 1 year earlier, in July 2024, Google DeepMind had already made headlines by reaching a silver medal standard at the IMO. Their systems back then, AlphaProof and AlphaGeometry 2, solved 4 out of 6 problems. That was groundbreaking, but it came with a huge asterisk. The process was heavily dependent on humans. Experts had to take the problems, which are written in plain English, and meticulously translate them into a formal, machine-readable language, a process that could take a considerable amount of time. The 2024 systems also took up to 3 days to crank out some of their solutions. Fast forward to 2025. The game completely changed. Google's Gemini DeepThink processed the questions directly in natural language. It read the problems in plain English, just like a human contestant would. This demonstrates a profound evolution from mere calculation to something that looks a lot more like genuine understanding and comprehension. It's the difference between needing a translator to understand a foreign film and simply watching and understanding it yourself. And it did this all within the strict high-pressure time limits of the competition. This leap from needing formal code to understanding natural language is perhaps the most significant part of the entire achievement. It's a move towards an AI that can think and reason in our world with our concepts, not just in the sterile logical world of code. So what kind of digital mind can perform these incredible feats of logic and creativity? The architecture behind this success is a beautiful concept known as a neuro-symbolic system. The best way to understand it is to use the thinking fast and slow analogy, popularized by psychologist Daniel Kahneman. Our own minds have two modes: a fast, intuitive, pattern-matching mode, and a slow, deliberate, logical mode. The AI was designed to mimic this. The fast thinking part is a neural language model. This is the component you might be familiar with from systems like ChatGPT or Gemini. It's trained on a colossal dataset of text and data, and it excels at recognizing patterns. In the context of a math problem, it acts like an intuition pump. It can look at a problem and quickly suggest potentially useful steps, interesting geometric constructions, or promising avenues to explore. It's the AI's gut feeling, saying, hey, what if we tried drawing a line here? Or, this looks similar to a theorem I've seen before. But intuition can be wrong. That's where the slow thinking part comes in, a symbolic deduction engine. This is the rational, logical component. It takes the creative ideas proposed by the language model and rigorously tests them. It uses formal logic and the strict rules of mathematics to check if each step is valid and if the proposed path actually leads to a sound conclusion. It's the skeptical partner that says, hold on, let's prove that this idea actually works. This combination is incredibly powerful. The neural network provides the creative spark, the flash of insight, while the symbolic engine provides the rigorous, logical verification needed to build a flawless mathematical proof. It's the perfect marriage of creativity and logic, all happening inside a machine. Now, to build that powerful, intuitive, fast-thinking model, you need data. A lot of it, and this presented a huge problem for the DeepMind team. To train an AI to solve problems at the level of the IMO, you need millions of examples of high-level problems and their solutions. But such examples are incredibly scarce. The entire history of the IMO only provides a few hundred geometry problems, for example. You can't build a world-class system on such a small dataset. So the researchers came up with an ingenious solution. If you can't find the data, create it. They built a system that generated a mind-bogglingly huge synthetic dataset. It started by creating billions upon billions of random geometric diagrams, just random collections of points, lines, and circles. Then, it used its symbolic deduction engine, the slow thinking part, to work backward. It analyzed each random diagram to discover all the possible theorems and proofs that were true within it. It essentially found all the hidden mathematical relationships in the random chaos. From this process, they generated a colossal, high-quality dataset of 100 million unique geometric problems and their proofs. The AI literally created its own perfectly curated textbook from scratch, a textbook with 100 million examples. This synthetic data was then used to train the neural language model, teaching it to recognize an almost infinite variety of geometric patterns and to develop that powerful intuition for what steps are most likely to lead to a solution. It's one of the most clever solutions to the data scarcity problem we've ever seen in AI research. This gold medal-winning AI didn't just appear out of nowhere. It was the result of years of steady, iterative progress. The foundation was a system called alpha geometry, first introduced in January 2024. This system was specifically designed for the geometry portion of the IMO. When benchmarked against 30 past IMO geometry problems, the first alpha geometry solved an impressive 25 of them, nearly matching the average score of a human gold medalist on that same set. But the team didn't stop there. They created Alpha Geometry 2, which refined the model even further. It expanded its formal language to understand more complex geometric concepts and dramatically improved its search algorithm, allowing it to explore possible solutions more efficiently. This new version could solve an astounding 84% of all IMO geometry problems from the past quarter century, officially surpassing the performance of the average human gold medalist in this specific domain. It was this supercharged Alpha Geometry 2, combined with other specialist systems like Alpha Proof for algebra and number theory, that formed the backbone of the system that won the silver medal in 2024. The 2025 gold medal systems, like Gemini DeepThink, represent the next step in this evolution. They built upon that powerful neuro-symbolic foundation, but integrated it with even more advanced large language models based on Google's Gemini architecture. They also introduced novel techniques like parallel thinking. This allows the AI to explore multiple completely different solution paths at the same time, much like how a team of mathematicians might brainstorm different approaches to a single problem. This multi-pronged attack greatly increases the chances of finding a valid solution within the tight time constraints of the competition. You might be wondering, we've had AI that can beat grandmasters at chess and Go for years. Why is the IMO such a big deal? Why has it been considered a grand challenge for artificial intelligence for so long? The answer lies in the nature of the problems. Games like chess and Go, while incredibly complex, operate in a contained environment with a fixed set of rules. An AI can win by being a tactical and strategic brute, calculating millions of moves ahead. IMO problems are a different beast entirely. They are open-ended, fluid, and often require a non-linear creative approach. They demand not just calculation but genuine insight. They require the ability to synthesize knowledge from different areas of mathematics and to come up with a clever trick or a novel construction that cracks the problem open. This is why many winners of the Fields Medal, often called the Nobel Prize of Mathematics, are former IMO medalists. The competition doesn't just test knowledge, it tests mathematical creativity at its highest level. For an AI to succeed here, it has to go beyond simple pattern matching and demonstrate a form of abstract reasoning that, until now, was thought to be exclusively human. The fact that an AI has now reached this level in a formal competition against the world's brightest young mathematicians is a profound statement about how far the field has come. So an AI has officially earned a gold medal at the International Mathematical Olympiad. What does this mean for the future? Is it the dawn of artificial general intelligence, or AGI, where machines become smarter than humans across the board? Experts caution against jumping to that conclusion. For now, these are highly specialized systems that have been extensively trained on mathematical domains. They can't write a novel or compose a symphony. The more immediate and exciting implication is the dawn of a new era of collaboration. This achievement signals a future where AI can serve as a powerful partner in mathematical and scientific discovery. Imagine a mathematician stuck on one of the great unsolved problems, like the Riemann hypothesis or the Goldbach conjecture. They could use an AI. I like this as an indefatigable collaborator, an assistant that can explore millions of avenues, check complex proofs, and suggest novel ideas that the human might never have considered. The AI could become a tool for augmenting human intellect, pushing the boundaries of what we know. The journey isn't over. While AI has conquered a huge part of the IMO challenge, it hasn't achieved a perfect score yet. That final combinatorics problem, P6, still stands as a formidable obstacle. Problems in combinatorics often require a very deep, almost playful, creative insight that is still proving difficult for AI to replicate. Researchers are exploring new paths to get there, including using reinforcement learning on high-quality math data and improving the AI's ability to break down enormous problems into smaller, more manageable parts. But the barrier has been definitively broken. a machine has officially demonstrated mathematical reasoning on par with the world's most gifted young humans. As these systems continue to evolve, they hold the promise of not just solving the problems we give them, but of one day discovering entirely new mathematical knowledge, helping us to understand our universe in ways we can currently only dream of. The age of the AI mathematician has truly begun. Thanks for tuning in to G Fun Facts Online. Join us next time as we explore another fascinating story from the world of science and tech.